G'day, my name is Hayden. I'm based in Melbourne, Victoria, and currently undertaking a Bachelor of Global Logistics and Maritime Management. My presentation today will last for approximately 10 minutes. If English is not your first language or you find it hard to understand me, please feel free to enable subtitles or closed captions by clicking on the button below. In the spirit of reconciliation, we acknowledge the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. This poster is going to help facilitate the discussion surrounding the reduction of greenhouse gas emissions in the maritime shipping sector. Just some quick facts about the maritime shipping sector. We have down here in the bottom part of the poster, over 80% of the volume of international trade in goods is carried by the sea. Maritime shipping contributes to roughly 3% of greenhouse emissions globally. There is some varying sources that range from 2 to 3, but most of them are at the higher end of that. The total value of annual world shipping trade reached $14 trillion US dollars in 2019. We did have COVID, which that figure did dip a little bit, but figures have recovered, and they're looking at roughly 7% compound growth per annum on that figure. Historically, oil-based fuels have met over 99% of the total energy demand for international shipping. So this poster here, we've got just some technologies we'll discuss and what the technology is, how it works, and just some examples of that technology in place. And just some of the issues that will face that transition and impact the goal of reducing greenhouse emissions in the maritime shipping sector. Just a quick statement up here, which is leading most of this change, is the IMO in 2023 sat down with 175 member states, and they all agreed on the strategy and ambition to reach a net zero greenhouse gas emission figure by around or close to 2050. Now, that's not legally binding, and we'll come back to that. But it is something to aim for, and there is interim checkpoints 2030, 2040 to reduce greenhouse emissions by those waypoints. But the ultimate goal is to reach net zero by 2050. Now, some of those technologies we'll be discussing artificial intelligence, alternative fuels, and ship design. We'll start off with AI, artificial intelligence, technology that enables computers and machines to stimulate learning, comprehension, problem solving, decision making, creativity, and autonomy. Now, how AI will impact the maritime shipping sector is will create route optimization, can assist in collision avoidance, will assist in fuel and engine management, so throttle control, fuel settings. Now, what that's going to do is it's going to increase the fuel efficiency of the vessel over the journey, which is good for the environment and will lower emissions ultimately. Will also, from a commercial side of things, save on the fuel bill. Stopford, in his maritime economics textbook, 2009, really hammers home that fuel is one of the biggest expenses when it comes to operating vessels across this voyage. So that's a big commercial management benefit there. Fatigue management will free up staff to make better decisions with the data they have in front of them as well, which ultimately is going to lead to better vessel performance. An example we've got here is Stena Line in Sweden. They've been able to reduce its fuel consumption by 1 to 5% using AI, analysing factors like wind, waves, and depth in real time to ensure efficiency, power output. They're not the only ones. The big boys, Maersk and CMA, CGM, they've also started to set up AI functions on their voyages to deliver a better performance and reduce maintenance by monitoring the ship's machinery to make sure it's running efficiently from a fuel point of view, but also any irregularities in the motors and machines, they can change the settings so they're not damaged, so they can reduce, um, increase the efficiency, make the engines run better with real time data. So that's fantastic. Now, there's a lot of data on this. There's a lot of data across all these issues, but we're just touching on it today. So we're going to move through. We've got 10 minutes. We're going to move into alternative fuels. Now, mentioned before down here, historically, heavy oil fuels have met majority of the energy needs for the maritime shipping sector, but they're looking at alternative fuels such as LNG, hydrogen, ammonia, and methanol. Pretty exciting stuff. These fuels will be substituted. New builds are being ordered for things like ammonia and methanol and dual fuel LNG. So they are in the pipeworks, which is great. Now, ultimately, how that's going to work is these fuels will burn cleaner. And I'll put a little star there because things like LNG, they might produce less CO2 emissions, but they, over the lifespan and the production of it, the LNG, they will produce high amounts of methane, which is not great. So things like hydrogen, ammonia, and methanol probably more long-term options. LNG is definitely a near future option that we could that is being used at the moment to lower emissions. Now, zero emission production, I've also put a star there. The creation of methanol can be done net zero greenhouse gas emissions if it's using renewable energy, which is really exciting stuff. Um, but we need facilities on shore, and we need major investment in infrastructure to deliver that zero emission production of that fuel. As mentioned before, a lot of new builds are getting done with these fuels in mind and being ready for the transition. But also vessels are being retrofitted, and there is a lot of data on cost analysis over the lifespan of the vessel, whether um, it is viable, and companies are doing it. So they are crunching the numbers and they are coming out that it is viable for some ships to be retrofitted for these alternative fuels, sorry. And another point from a commercial point of view, commercial management, is it's very attractive to the customer to know that the logistical network they're using is moving towards zero emission production. So we've got an example with Maersk there. Um, they've put a lot of time, money, and effort into decarbonising their fleet, and all their new builds are being ordered with dual fuel and ready to go for alternative fuels as well. Uh, so they're looking at not only retrofitting but also taking delivery of brand new vessels. So every vessel that will be retired will be replaced by a more energy efficient and lower greenhouse gas emitting vessel. So Maersk actually in 2023 took delivery of the world's first container ship operating on green methanol. So that's produced by using by renewable energy, the creation of that methanol. So fantastic. So that's a world first, and they're leading the way, which is really really good because they can lead by example and show that it is economical, and then a lot of other companies may follow suit. So moving on quickly, we've got ship design here. Things like hull design, wind-assisted ship propulsion, things like sails and um, kites being attached to the vessel. There's solar panels and batteries. Now, these solar panels and batteries work well in combination with hydrogen and ammonia in the fuel cells. So that's all integrated together. Um, when those ships have been designed, when a fuel alternative fuel source has been decided on. Now, some of these benefits, from a your physics point of view and mathematical point of view, it can be less drag, better fuel economy, lower operating costs, less wear and tear on machinery, which all, in the long run, lowers greenhouse gas emissions. Now, an example, we've got the Cargill shipping there. We've got they've actually started doing trials with wind assisted propulsion called WASP as an acronym. And the ship called Prixis Ocean has two wind wing sails installed on the deck. These sails are 7.5 meters tall, and they're made from the same materials as wind turbines for durability. And it aims to reduce the carbon emissions by 30% over the lifetime of the vessel. So they're saving roughly 3 tons of fuel per day using these sails. Early experiments are showing. So from a commercial point of view, less fuel, less operating costs. So it's a very attractive benefit of that technology. Now, some issues we face with these technologies when we put them all together. With the AI, we definitely have privacy and cybersecurity issues. We also have regulation when it comes to autonomy. And there's still a lot of concern about liability when artificial intelligence is operating or assisting vessels at sea. As mentioned previously with the alternative fuels, there's high levels of capital investment required, not only in the vessels themselves, but also onshore facilities and the handling of these fuels, and along with their production and storage. The transfer of the fuel is also causing some problems too to some vessels. It's been documented. I've got to keep moving on here. Well, I touched before about how the strategy released by the IMO was not legally binding. Um, there's actually the regulations between different nations has also been a little bit of an issue where different nations or bodies such as the EU have different emission standards that they want vessels to adhere to. So rather than just we can't just get a blank booking across the planet of what regulations are, because some poorer nations might find it hard to actually get to those standards, and might shun them from the actual equation. So it's important to remember that. But also things like training and safety. Um, these are big issues when it comes to alternative fuels. It's been documented that methanol acts differently when it's on fire to traditional fuels, and traditional firefighting and suppression systems are ineffective. So that's going to take some. That's how to integrate the ship design to deal with that, but also it's going to have extra training and training costs to provide a safe environment for its workers. And quite often, that extra training is going to mean that some crew members can't transfer to other vessels easy enough without further training. So that's going to be a little bit of an issue as well. Um, Another issue that we came across during your research was the supply of fuels and ensuring that the supply of the fuel is there. So if you do have a vessel that's running purely on a chosen alternative fuel, we've got to make sure there's the availability of that fuel as well. Okay, there's plenty of literature on these technologies and moving forward to zero greenhouse gas emissions out there. I've only just touched on a few things today. My time is up, unfortunately, but I will post a link down below regarding the IMO's 2023 strategy for you to glance over, because that will have some further information on it. And this this is not going away. This is only going to be intensified as time goes. So watch this space. There will be further investment. There will be new technologies come along. There will be new issues that are identified, just like this iceberg probably represents. There's a lot under the water we don't know yet, and it will come to the surface, and it will have to be dealt with. Because this number down here is 3% doesn't look like much, but when you think about it in the whole scheme of things, one aspect of our lives, global transport, that's quite a big number. So thanks for your time today. Thanks for listening. This is a big issue, and I've only just touched on it. So I hope I hope I've made you think a bit more about it and go away and do your own research. There's plenty of it. So thanks very much for your time today. Appreciate it.